Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and if you're enjoying our show, we'd really appreciate it if you could rate us on your favorite podcast platform. Today we're diving into distributed file systems, which is part of our chapter on decentralized storage systems. Before we get started, I have a quiz question for our listeners. What's the estimated size of the largest IPFS network in terms of the number of nodes? Victor, what do you think about this question?
That's an intriguing question, Sheila. It really makes you think about the scale of decentralized systems. Without giving away the answer, I think it's a great way to get our listeners thinking about the potential reach of distributed file systems. The number might surprise many people who are used to thinking about traditional centralized storage solutions.
Absolutely, Victor. Now, before we dive deeper, could you give us a brief explanation of what a distributed file system is?
Certainly, Sheila. A distributed file system is a file system that allows multiple users on different machines to share files and storage resources. Unlike traditional file systems that are centralized on a single server, distributed file systems spread data across multiple nodes in a network. This approach offers benefits like improved reliability, scalability, and fault tolerance.
That's interesting. So, it's like having a decentralized library where books are stored across multiple locations instead of in one central building. How does this compare to traditional file systems that we're more familiar with?
Great analogy, Sheila. In a traditional file system, all the data is stored in one place, like a single library building. If that building is damaged or inaccessible, you can't get to any of the books. In a distributed file system, it's as if copies of books are stored in many different libraries across a city. If one library is closed, you can still access the books from other locations. This redundancy makes distributed file systems more resilient to failures.
I see. So, resilience is a key advantage. Are there other benefits to using a distributed file system?
Absolutely. Besides resilience, distributed file systems offer better scalability. As the amount of data grows, you can simply add more nodes to the network to increase storage capacity. They also provide better performance in many cases, as data can be accessed from the nearest or least busy node. Additionally, they enable better collaboration, as multiple users can access and work on the same files simultaneously from different locations.
That makes sense. Now, you mentioned IPFS earlier. Can you tell us more about what IPFS is and how it relates to distributed file systems?
Certainly. IPFS, or InterPlanetary File System, is a protocol and network designed to create a peer-to-peer method of storing and sharing hypermedia in a distributed file system. It's one of the most prominent examples of a modern distributed file system.
Interplanetary File System, that's quite a name. Why is it called that?
The name is indeed attention-grabbing. It reflects the ambitious goal of creating a file system that could work across vast distances and different planets. While we're not quite there yet, the name emphasizes the system's design for extreme scalability and resilience.
Fascinating. How does IPFS work differently from traditional file systems?
One of the key differences is in how IPFS addresses content. Traditional systems use location-based addressing, where you need to know where a file is stored to retrieve it. IPFS, on the other hand, uses content-based addressing. This means that instead of referring to a file by its location, you refer to it by a unique fingerprint of its content.
Content-based addressing sounds interesting, but I'm not sure I fully understand it. Could you explain it a bit more?
Of course, imagine you have a book. In a traditional system, you'd look for it by its shelf number in a specific library. With content-based addressing, you'd look for it by a unique code based on the book's content. This code would be the same no matter where the book is stored. In IPFS, this unique code is called a content identifier, CID. When you request a file, the network finds the nearest node that has a copy of that content, rather than going to a specific server.
That's really cool. It sounds like it could make data retrieval more efficient. Are there any challenges or drawbacks to this approach?
Good question. While content-based addressing has many advantages, it does come with some challenges. For one, it can make updating files more complex. Since the address is based on the content, Any change to the file results in a new address. This can make version control and tracking changes more difficult. Additionally, if a piece of content is not popular and not widely replicated, it might become unavailable if the nodes storing it go offline.
I see. Are there other distributed file systems besides IPFS that our listeners should know about?
Absolutely. While IPFS is quite popular, there are several other noteworthy distributed file systems. Some examples include Storj, which focuses on encrypted, decentralized cloud storage, and SIA, which aims to leverage unused hard drive capacity around the world to create a data storage marketplace. Each of these systems has its own unique features and approaches to decentralized storage.
It sounds like there's a lot of innovation happening in this space. What do you think are some common misconceptions people might have about distributed file systems?
One common misconception is that distributed file systems are always faster than centralized systems. While they can offer performance benefits in many scenarios, factors like network latency can sometimes make them slower for certain operations. Another misconception is that they're automatically more secure. While distribution can enhance security in some ways, it also introduces new security considerations that need to be carefully addressed.
Those are important points to keep in mind. Before we wrap up, could you share a fun fact or interesting anecdote about distributed file systems?
Sure, here's an interesting tidbit. IPFS played a crucial role in preserving and distributing information during the COVID-19 pandemic. When the Chinese government took down an article about the virus from a news site, people used IPFS to ensure the information remained accessible. This demonstrates the power of distributed systems in preserving information against censorship.
Wow, that really puts the importance of this technology into perspective. Now let's reveal the answer to our quiz question. The estimated size of the largest IPFS network is over 200,000 nodes. That's a massive distributed system.
Indeed it is. It's amazing to see how these systems can scale to such large sizes.
Absolutely. To summarize what we've learned today, distributed file systems offer a decentralized approach to file storage, providing benefits like improved reliability, scalability, and fault tolerance. IPFS is a prominent example, using content-based addressing instead of location-based addressing. While these systems offer many advantages, they also come with their own set of challenges and considerations.
That's a great summary, Sheila. I hope our listeners found this deep dive into distributed file systems informative and engaging.
Me too, Victor. And to our listeners, if you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy coding.